Uh, oh, yeah. That's, it's making a noise. What do I happening? The London Museum of Water and Steam? Oh, now we're in for a treat. Oh, yes. That's better. I wish this would stop making noise so I can appreciate that. Teleport. Ha! Okay, I've just got to chill out. Uh, 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 thumbs. Thumbs. Hang on, I want to read this. Welcome. We are just... Here did I... No, okay. London Museum of Water and Steam. Okay, I got it. Welcome. We are just loading the museum for you. Does that line up with the eye? I don't know. While we are doing that, please feel free to try starting the steam machine by clicking on the green button. Once the museum is ready, step into the green cylinder to proceed. Oh, interactivity. Oh, yes. Oh, hang on. Now, how did I... Oh. How do steam engines work? This is exactly what I want. This is it. Okay. Oh, ladies and gentlemen, you're in for a treat today. Can I do this? Yeah, How do steam engines work? Why, with the expansion and retraction of cylinders and gases. Oh, this is one. Okay, this is an interesting fact. There were, of course, originally, before the steam engine got properly advanced, there were atmospheric engines, which... Oh? Where's my head? I don't want to get distracted by that. I want to be distracted by this. Now, okay. Steam... What just happened? I don't know. Okay, right. So, there is atmospheric pressure. That is the pressure of the air that is being pushed onto us right now. And that is measured in pounds per square inch, or PSI. And so you could have a lower pressure. They were vacuum engines, although not technically pulling a vacuum. They were trying to draw a vacuum. They were very inefficient at that point, so what you would do is you would generate as much negative pressure as you can. Of course, it's not actually negative pressure, but comparatively, a lower pressure than the outside air, which would force a cylinder down until eventually we got good enough that we could use positive pressure, so the pressure inside something could expand and move a piston rod. So here we go. Ah, yes. Yes, wonderful. Yes, so what we're seeing here, is, oh, hand's doing a thing. Can I can't, okay. Oh, goody! Oh, very nice. So, what we have is, I can't see where the inflow of steam is coming, but we'll just assume there is one. And, I can look at this diagram. Can we, Yes, wonderful. Okay, so, this is a pressure cylinder. This is a pressure cylinder. So inside of here, which you could see on that diagram, we would have over here a point at which we can inject the high-pressure steam, and there is a piston inside here. This is the cylinder in which the piston resides, and the piston is a large flat thing which fills up to the edges of the cylinder. So steam will be pushed into here, which will want to expand. That expands, pushes that out, as you can see there, which is then moving this. Now, how do you change? And then we off-gas or release that pressure, as you would see in that diagram there, at which point the pressure of the outside air would be lower than inside, which would push or force that back there. Now, also, that probably wouldn't be enough to get the piston to return to its point, which is where the flywheel comes in. So we get an amount of motion from here, which is converted. We'll get into how you convert linear motion into circular motion in a moment, but we'll just you just got to trust me that it does for the moment. So we get enough force to drive that going and moving that forward. Great. Now we've got a little thing called momentum. Momentum is the tendency for an object to keep doing what it's doing. Now, so what we do is we build up that momentum. Steam forces the cylinder that way. And there it goes. That's what it's hypothetically doing. Yes. Now, once we've transferred energy into this flywheel, it wants to keep doing that. It wants to keep rotating. And that flywheel is of sufficient mass that as it rotates, it draws, here we go, and it pushes that rod back into place, at which point we can repeat the process. Steam fills it up. Now steam goes out. Steam's filling up. Steam goes out. And that's great. Now, to get the reciprocal motion, what we have is, I think what that said was eccentric. Eccentric, yeah, yes. Now, so the actual point at which this is rotating is hypothetically in the perfect center. Here, there. Here, there. And here. Okay, so that's what we don't actually have a good coupling here, but I assume that's just to show what's happening. It'd be a good coupling. I don't know how they're theoretically joined there, but we're assuming they are theoretically joined there. So as that is pushed forwards, what we have to do is get an eccentric bearing. Now, can I see this from the side? Yes. Yes. So we've got the... oh no, I don't want to be inside there. Oh! Yay! Okay, so here, this is the, I suppose it's the moment. It's the central point at which everything is rotating. And this is the... Oh! Okay, well, this may be the moment. Who knows what the moment is? But this is the point at which force is being applied. Now, if we imagine it stopped there, and then you were to force it forward, it would start to go like that, at which point the eccentricity of this flange, we'll call it, the eccentricity of that allows it to move up. Now, what you would really want to do is not cold start it just by that. You would want to get the flywheel going just so that you're not trying to... I mean, if it were to stop at that point, just in the perfect center there, it would just try and force it forward, and nothing would happen. So you've got to... It's all about timing. Timing is a big deal. But this is excellent. This is excellent. Let's look more at... Let's look more at this. Wonderful. Yes. Pressure in. Okay, red pressure. Yes, as you can see, that's the pressure. That's the steam we're talking about. It's the steam and steam engine. Oh, wiggly. Steam is pushed into the back, and then we have the old gas being pumped out the back. So as this is being pushed out, it's pushed out. I'm saying push and pull so much. I suppose I should just let this speak for itself, shouldn't I? Wonderful. feel free to enjoy that. But I would love to watch that go. But there's more, I have to assume. So, hey, oh, why, hey. Wow, so this is London, is it? Arrow here. There's some sort of ribbon snake. It's attached. It's attached to the Vivian. Okay, right. So I'm to assume that I go in here. Oh, the door's opened. Oh, the door's open. This is very shimmery. Something wrong with my glasses? Oh! That's unpleasantly loud. Oh. Ah. Oh. Crumble. Crumble crackers. Hang on, I'm gonna ask my assistant to help me with that. Because that's very loud. Hang on. One moment. Okay, that's been adjusted for me. Still a little loud, but I'll be okay. Oh! A chair. Oh. What's happening there? I don't know. Oh. 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 Wow. Are these the bathrooms? There's no way to tell. I can't go behind there. Oh, you know what it'll be. Ah, the waterworks. Your journey through the history of London's water begins this way. Ah. Huh. Oh. Oh, now the sound's gone. Sound's gone quite unsoundy. Ah, okay. Which way do I go? Oh, I can't look that way. Okay, if I look too far that way, everything goes away, so I can't look at this. Did you block the sewer? Not me. Oh, wonderful things. Not to flush down the toilet. Well, you know, sewage works. I thought... My mind can't comprehend that. And I can't lean on that. Okay. I'm going to try and put that out of my mind. I don't know whether you know this. If you're old enough, put your hand up. But you didn't always have sewer systems. Shiny. One of the vast improvement in quality of life. Sewage systems. It makes everything better for everyone. It's you don't think about sewage enough. I mean, you don't want to think about sewage, but sewerways exceedingly important. And the fact that you don't think about it is testament to how well it works. And if you've got a problem, you've got a big problem, and that's when you know. But but everything's working fine. If everything's working fine, then your life's a dream, basically. Nope. I don't know whether it's which way am I? Oh, that looks like a pressure cylinder. Oh, this is which? Oh, now this is the stuff. Oh yes. Oh, ladies and gentlemen, this is the dream right here. Could I go Could I go up? No, I'd like to go up. But I guess I can't. That's fine. It's fine. I shall enjoy that. Now there's a flywheel. Oh! Now would you look at that? Would you look at that? Now we were talking about eccentricity. That's a crankshaft right there. Now we've got eccentric. Ah, now this is a fascinating thing. So, can we turn that? The best steam, the best ever steam pumping engine. That's controversial. The triple expansion engine is one of the most efficient and well-engineered steam engines ever used for water supply. Yeah, and of course, huge boon for various navies. The triple expansion. If you've ever had any interest in the history of naval shipping and navies, shipping, freight, also, I mean, I'm firmly in the train camp, but the steam engine was not just a boon for the train, it was for land. In fact, steam may have been more useful for being popularised by ships and boats. It depends on your opinion and your sources, of course, but relatively early adopters, the ships. Oh, I can't look that way. You know. Huh? Ah, yes. Oh, her hand. Okay, right. Let's figure this out. Oh, this is one. Ah, yes. There's we've got a governor right there. Now, this is a fascinating design, the governor. Now, it's a form of pure... how do I phrase this? The conservation of angular momentum. So, if you were to stand with your arms out like... Well, not that. If you were to stand with your arms out like that, and then spin around, which I can't do at the moment, and then try it again, but doing that, you'd find it a much easier time with your hands in here, rather than that. Now, this is because of levering forces and what some may call centrifugal force, but centrifugal force it doesn't technically exist. But for the demonstration purposes, we're gonna assume that a centrifugal force does exist. No, we're not. I can't do that. And anyway, the further out from the centre of rotation something is, the more energy or the harder it is to get it to spin. So this is where the rotating governor is fascinating. Now, this is a way of controlling speed without introducing mechanical wear and without digital control. This is purely analog. As those, you see there, those little rods with balls on top, those, I don't know whether it's modeled correctly here, but those can, let's assume this is the central point, and then we've got the, you have to imagine we've got two balls around that, but at rest, they're very close in, which means it can spin very easily. But as it gets faster, they start to cant out, and as they cant out, that's okay. Now so as they cant, now these are the two flanges there. Okay, so like this, they spin very easily. If they were to go out, the faster they go, the more out they go, which means it takes it's harder to drive them doing this, which ends up regulating how fast it goes, because the faster it goes, the more work it has to do to make it go faster. And now you're not introducing any more mechanical wear via resistance. I suppose you are, because there's torsional forces. But this is that's a wonder right there. And then we've got the eccentricity of before. Probably belts that you can't see here. Probably should be belts transferring force from the flywheels, but maybe they're there and I just can't see them. What we're seeing here is the eccentrical movement that we saw earlier, except we've got far more chances of doing it, and this is working on the exact same principle. Of course, it's an advancement of the atmospheric engine, so it's no longer pulling vacuum, but instead inducing positive force inside cylinders, and so on. Oh, that's a wonder, that is. Let's look at this. Let's look at this. This might have to be a multi-episode thing. This might, if I can find more time to look more around here, I should greatly enjoy it here. Thank you so much for joining me, ladies and gentlemen. I shall hope to be back if there is more content here. I'm afraid this is not a museum I've been to in the real world, so I can't tell you how much more there is. If there's more, I'll be sure to show you. This has been wonderful for me. Thank you so much, ladies and gentlemen, and I shall see you in another time. Hooray! You have to imagine I'm doing a thumbs up there.